Chapter 3, Section 8, Explicit Formulas for the Arithmetic Sequences. Given a choice, I prefer this equation. It's much more powerful. You can do a whole lot more with it. Come test time, just like the recursive formula from the last notes, I'm going to ask you to know this thing from memory. But the equation is a sub n, the nth term, equals a sub 1, the first term, plus n minus 1 times d. That's often how you see it done. Sometimes they're going to take and put the d here in front, which there's some perks to that. I'm going to actually just leave it this way though, but you could write it the other way if you want to. Equation then is going to be that. Know it from memory come test time. Finding the equation. Maybe I should make the comment, just like before, when we had the recursive formulas, we filled in two things. We filled in what the first term was, we filled in the constant difference when trying to write out an equation. And we'll do that same exact thing when we're doing the explicit formulas. And like always, when I'm trying to get you to memorize an equation, I encourage you to actually write it out as you do the problems. And then if you do that enough times, well, one, you're more likely to get it right, and two, when you get to the test time, you're just going to know it from memory anyways. Alright, so here's my first sequence, 5, 8, 11, 14, 17. I want to write out my formula, and to do that then, I say the nth term, a sub n, equals the first term. That's going to be my 5, so I just plug a 5 in there, plus n minus 1, and we put in what d is. And d in this case is 3. If you look, each time it goes up by 3. If you're ever not sure, take any number in the sequence and subtract the number in front of it. 8 minus 5 is 3. 14 minus 11 is 3. So you can find the constant difference that way if they're tough, or you could go back and check, is it really a sequence? Do that for the different terms in the sequence. But this here is a legitimate form. A lot of times people look at this and it just totally blows their mind because they say, okay, it's times 3 here, but that's wrong. I'm adding 3. And the addition really shows up here at this point. What it's really doing, this formula, is it's saying, well, here I'm starting at 5, and I'm adding 3 one time less than the term number. And if you look at that, it makes sense. If I want to get this 11, I start out at 5 and I add 3 twice. So when I'm talking about my third term, I take my 5 plus 3 plus 3. I take my 5, I add 3, third term minus 1, so 2 times. If I'm looking for the 14, the fourth term, now I have to add 3 3 times. So I take my 5, I add 3 3 times. The fourth term, that's going to be 4 for a sub 4, minus 1 gives me 3 times I'm adding 3. Alright, erased a little bit too much there. Let's go on and do the other example. You probably all copied it down, you're just waiting for me to go. Oh, I just did something ugly. We'll just leave it that way. Alright, this one here, I'm going to follow my own advice and write out the equation. So the nth term is the first term plus n minus 1 times d. And now, see, my nth term is my first term, a negative 4, plus n minus 1. Now here really is why I wanted to include this example. My d is going to be a negative 5, and again you could, if you wanted to, say, well, what is it? Negative 9 minus the term in front of it, so negative 9 plus 4 gives me a negative 5. And the point I'm trying to make is sometimes people have this look way too much like a n minus 1 minus 5. So make sure it's very clear that you are multiplying by a negative. Have the little minus sign up above, preferably put the little dot in there also to show its multiplication. The next example I want to do is going to be finding a certain term in a sequence. Nice part about explicit formulas, you can jump right to the term as opposed to having to find all the ones before it. So here I have an explicit formula, a sub n equals 14 plus n minus 1 times 8, and the problem is saying find the 23rd term in the list. Well, it's really not a bad problem as long as you see one thing. That's if I'm looking for the 23rd term, it's a sub 23, which then tells me my n value has to be 23. So when you have an n later on in the problem, you just make that 23. So I have 14 plus 23 minus 1 in parentheses times 8. So to get that 23rd term, you start with the first term, the 14, and you're adding 8 22 times. Punch that into your calculator and you should come up with 190. So the 23rd number in that sequence, the 23rd term, is 190. Now if you look, the next example is real similar to this in wording, but it's different, in a totally different process. So finding a term, you're looking for a certain number in the sequence. So 190 would be the 23rd number, the 23rd term in the sequence. My next example is that you're trying to find a term number. So what this is it's giving you the number in the sequence and it's saying, is it the 5th number? Is it the 17th number? Which term, which number in that list of numbers is it? So you need to be careful when you see a question that says what term is 390s, is in math languages equals, it's saying what number in the list equals 390. Okay, so if we were looking for the 390th term, we'd put it in for n. We're not looking for the 390th number. So we put it in for our only other variable. We know that this random term, this nth term in the sequence, is equals 390. So 390 has to go in for a sub n because it's the nth term in the list. And now the question just is, what's n? Is it the 23rd term? Is it the 58th term? Which term is it? So if we put in the 390 and copy everything else down, this is where I really encourage you to show your work and not just try to do it all on your calculator. It's real common that people are off by one number. If it's the 54th term, they'll say it's the 53rd term or something like that. Alright, so we're solving for n, so we do order of operations backwards. We can't do anything with this because it's in parentheses, so we look at this 14 here. It's tempting to say we have to subtract because of this plus, but you always look at the sign in front. It is connected by addition or subtraction, so we do need to add or subtract, but you look at what sign is there. It's a positive 14, so we start out by subtracting 14 from both sides of the equation, and that's going to give us a 376 equals, that's gone, so n minus 1 times 8. We still can't do anything there, so I maybe should write this down. So order of operations, we're doing those things backwards since we're solving for a variable. So we did our addition and subtraction. Now we look at what's connected by multiplication or division, and we have this times 8. So you say, well, what's the inverse? What's the opposite of multiplying by 8? And that's dividing by 8. So I'll see if I have this in my notes. Yep, that gives us 47. So 47 equals this n minus 1. You could, a lot of people still put the parentheses around there, but you don't need the parentheses anymore. It's not separating it from anything. So you could, if you wanted to, get rid of those parentheses. Let me drop that off of there a sec. And okay, so 47 equals n minus 1. Here's a step that people miss. When they're just doing it in their calculator, often they forget to add 1. And once you do that, now we find that n, the term number, is 48. So 390 has to be the 48th term in the sequence. The very last thing I want to hit in section 8 is how to find 4 terms in a sequence. There's 2 ways to do it. A is kind of the, if all else fails, do it that way. If you're not very good at math, sometimes those people go with A. B is just way easier if you see it. But starting out with A, if you're trying to find the first 4 terms, you could say put in n equals 1, because that'd be a sub 1, the first term. N equals 2, that would find a sub 2, the second term. N equals 3, and n equals 4. And I'm assuming that you're actually going to do the math each time. So when you do that, your first term then is going to be 4 plus 1 minus 1 times 3. And some people actually type this whole thing in exactly how it's written with their calculator, press enter, then they can do second enter, and then just go back and change that 1 to a 2, and then have that work out as well. I'm not going to bother doing that right here in front of you, but so the first term is going to be 4 plus 1 minus 1, so 0 times 3. So 0 times 3 is just 0. so we get a 4. The second term then, this becomes a 2, so 4 plus 2 minus 1 times 3, so 4 plus 1 times 3, 4 plus 3 gets us a 7. The third term then, a sub 3, and now we'd have a 3 in for n, and this is then going to be 2 times 3, or 6, 4 plus 6 is 10, and then the last one, a sub 4, try to squeeze it in there. If we put a 4 inside the parentheses, we end up with a 3, so we have a 9, 4 plus 9, 13. So that's kind of the fallback. That's definitely the slower way to go about doing it. B, the one I prefer, is I'm going to just write find a sub 1 and D, the constant difference, and go nuts. It's not really math language there, but we'll stick with it. So if the formula is written nicely in that explicit formula form, it's going to be a whole lot easier to just say, well, it's a sub n equals a sub 1 plus n minus 1 times d. This gets a little bit tougher if you don't have the formula written out nicely like this. You could manipulate it, move things around a little bit to put it in this form. But the nice part here is you can just say, well, hey, look, my a sub 1 has to be 10. Kind of lost my 1 there. And my d is going to be a negative 5. So my terms are going to be 10 for the first term. Then to get each term, I take off 5. So 5, 0, negative 5. Then you could just keep going, negative 10, negative 15, negative 20. If the math is tough for you or the number's not as nice as mine, you could go with your graphing calculator and do your 10, enter, and then minus 5, and when you do that, this little ANS should appear on your screen. And then just every time you hit enter after that, so enter, enter, enter. Every time you hit enter, it's just going to give you the next number in the sequence.